Okay, in this session we are going to have a code demo on using the statistical models for POS tagging. So we have already seen statistical model like HMM and CRF and other methods MEMM. So today's demo we will be giving a kind of understanding on how hidden Markov model and CRF works for POS tagging context. So for doing this one, we have to import the libraries and also the data set. The data set again comes from NLTK. So we have imported the NLTK and we are also using an NumPy and pandas for the data classification and data manipulation stage later. And sklearn already have some kind of inbuilt thing, but we are using it for our train test split and classification report and accuracy score. So let's use this particular library. Okay. And of course, initial thing we are downloading the tree bank from the corpus, and also we are downloading the universal tag set, and now we are reading that tag set. You could see this is being read. Now we want to see how this data set looks like. So the first two sentences from the data sets is being actually iteratively pass on to a particular tuple, and you could see their first two sentences with the word and its POS tagging. So, and again universal tag set in NLTK do not have the difference between proper noun and noun. So similarly, as you see, PID Winken, it's given as noun and also noun here. And also the auxiliaries are also being normalized as verb. So that's why will and join are given as verb and verb. So after this stage, we have to get the split the data into training and validation. So we are using again the library to sklearn library to split the data into the training and the testing with the ratio of 80:20. Once this is being done, we are creating the train and test data in a variable. So we are passing on to the each of the sentences, and we are creating a variable called train and test. Once we created the training and the data set, we are creating the variables for the train tagged words and test tagged words. And now you could see the size of the trained data and the size of the test data. So now once this is being done, now we have to set the data set type to check whether there are unique tags that are present in the training set, because we want to know what are those unique labels that are being used. So, so as you could see, the unique labels in this particular data sets are like 12 unique tags: number, verb, adjective, particle, adverb, conjunction, dot, x, determiner, ADP, noun and pronoun. So proper noun and auxiliaries and other categories are not being present in this data set. So in HMM, we have to do two things as we just seen. One is we have to compute the emission probability, and also another one is transition probability. Emission probability, as you said, a given word, and how likely that particular word can be tagged with a particular label. And transition, how likely it can be tagged by looking at the neighboring words tags. So this is being computed as we just explained using this particular definition. So now we are getting the words in the bag, and we are trying to find out how total number of times the pass tag with the given train bag, and finally we are calculating the total number of times the word occurred with the possible tag. So then we are returning it. And similarly, the transition probability is also being computed. So transition probability requires the next word and the previous word's knowledge. So T2 given T1 is being used here. So we are trying to utilize this pair and identify how many times the T2 and the T1 occurring together, and how many times when they are occurring together the particular tag is being used. So that's been identified here. Once this is identified, we are trying to convert this whole information into a matrix, so that this information is being used for the modeling purpose. So you could see especially the transition matrix of the thing which are used for this particular transition probability is being converted into a matrix like this. Now this matrix actually, if I convert it into a more better readability format, like for better data, the same matrix is being converted like this. So for example, there are tax matrix. So the tax matrix actually reads, this is the transition table which are shown in this article, and also it displays the difference between this tax matrix versus the words that are being identified through the number or other labels. So as you could see here in this data, so the number followed by, let's say, a noun is again always a higher, in the higher probability n, right? Similarly, verb followed by, let's say, dot, maybe a lower probability, but verbs followed by, let's say, another noun is in the higher probability, right? So determiner, let's take determiner followed by a noun is always in the higher end of the probability. So this is the data point that we are trying to get from the transition probability. Now we can also use Viterbi algorithm, because we know that there are hidden states. That hidden states sequence can also be used to identify the better probability. So now the Viterbi algorithm identifies them, initialize the probability, and I compute the emission and state probabilities together, so that we are trying to get the state probability which actually expresses the hidden states of the the whole probability chain here. So now using this one, let's randomly select some 10 sentences to test whether this probability works or not. So we are randomly selecting the first 10 sentences and trying to see whether this can be also been converted into testing the data set. Now since we have selected only 10 sentences, the whole training set takes a huge amount of time. So let's see how it's been running. Now for the 10 sentences, this actually Viterbi algorithm is being run. We'll see how much time it takes to get run that particular data set, and also we'll see the Viterbi algorithm's accuracy. So let it run. So let me also explain how to test it with some sample sentences. We can also test it by giving any sentence given here, and we can see, okay, from that test Viterbi algorithm that we have built, can you test it? Okay. So now it has actually identified with 93.77, and it took at least 36 seconds. Now when you run this Viterbi model with the sentence like Will can see Mary, so now you could see it has identified something, but let's say Will and Mary is being identified with particle, because given limited data set, it identified only this particular thing. Okay. And similarly, category wise precision and recall and FN score can be also identified. So for this one, again we are using some kind of classification report. So this classification report runs this test data and takes this one. So the labels from the PO's test data set and also predicted text from the test set, both are being used to generate the classification report. So this classification report with the limited data set that we have run shows you the different kind of precision, recall and FN score here. Okay. Now let's get back to the demo of CRF. For CRF, again we are using the sklearn CRF suite for our demo purpose. There are a lot of other CRF suites are also available, so we can still use them. So let's say it takes little bit of time to identify all the package, collecting the package. So it takes little time. Once this has been done, we are again using the NLTK and sklearn libraries to get the data set and other purpose. Okay, let's take them. Once this is done, we are actually downloading the tag sets from the tree bank, NLTK tree bank and universal tag sets, and you could see this is being downloaded, and we are also printing the first 2 sentences along with the tags, the similar thing. what we have seen in the HMM thing. And the next step is we have to split the data into the training and the validation set, again with the ratio of 80:2, 20. That's been done here. Once that is done, in CRF, again we can use different kind of features from the corpora. So the features, to extract the features, we are defining like word to feature kind of algorithm here, and this creates the features from different kind of information. There is a constant feature, that means that particular word, and the word in the lower case, the last 3 characters of the word, 2 characters of the word, and whether the word is in the upper case or not, or the title case, the first letter is been capitalized or not, and whether the word consists of any digit. All these informations are being used as a feature now. Once this feature is being used, now we have to check whether the previous word is there again with the given word or not. So it indicates whether if there is no previous word, that is the start of the sentence. When there is no following word, then it is the end of the sentence. So that's been calculated here in this kind of stages. Then finally we are returning the feature. Now what happens is, now we are converting the entire sentences into features by applying this word to feature technique. And we are also extracting the pure tags from the sentence, because we are assuming that each sentence is a list of tuples, that means a word and a tag. Now we are creating something like sentence to tokens. So extracting tokens from a sentence is what is being done here. Once this is done, we are converting the sentence into the feature. Okay. For example, if you take a word like drink, you see the last 3 words are I and G, that's a character, and the N-2 context is NK, and it is an uppercase false, and all these other feature informations are being given. Now we have to extract features from the data. That's what we have done for the training set here. So for the training thing, we are extracting the list of features that are there in the sentence for the from the the features that we have identified. Similarly, we are creating something called X-train and Y-train. X-train is nothing but a list of feature dictionaries for each sentence in the training set, and Y-train on the other hand is a list which each inner list contains the pure stack, again the corresponding sentences in the training set. And similarly, we are creating something called X-text and Y-test. And X-test is again feature dictionaries as we just created, and Y-test is nothing but the inner list where each of the word and their POs, corresponding POs tags. Once this is done, we can train the model. So we are using the CRF suite from the sklearn. So it uses some kind of optimization algorithm. It uses L1 regularization and L2 regularization, so that sparsity and overfitting are being taken care here. Once this is done, it trains that algorithm. Now we can test it using the test data that we have created. So for the test data, again, I'm sorry, there is some kind of running error. So for the test data, we have used the feature extracted test data and also the inner layered pure stack set. Once this is done, we can calculate the category wise precision and recall and FN score, similar to what we have done for the HMM context. So now you could see the precision and recall and FN score of each of the model. So the accuracy right now is 0.97 for this given data for this using CRF model. Thank you.